All right, let's check out the properties of sigma notation. And these are very similar to the properties that we've seen with limits, with derivatives, and with integrals for the most part, except for maybe this last one's a little specific to sigma notation. But first one is here we have the, if we take the sigma of a constant, then it's just n times the constant. So for example, if I have sigma from 1 to, let's say, 7 of, let's say it's a constant of 4, okay, then there's no place to put I in here. So it's just going to be 4 every time, right? It's just constant. But I'm adding this up 7 times, right? So I start at 1, so this would be like inputting 1, which I get 4, inputting 2, inputting 3, inputting 4, inputting 5, inputting 6, inputting 7. And so you really just end up with 7 4s, and 7 times 4 is 28, right? So that's why you just multiply the constant times however many that you're multiplying by, right? However many, how many that you're adding, I should say, right? As long as you're starting at 1, this is true, right? If you go from 1 to n, that means you're going to be adding n of these constants. And so another way to say to add n constants is to multiply n times the constant. All right, so these next ones, these ones are the ones that are actually more similar. That first one was a little different. But this next one is if we take the sum of a constant times a function, we can just multiply the constant on the outside and take the sum of the function. Okay, so we can bring the constant to the outside and just multiply. Here we have our sum and difference properties. So the sum of a sum is equal to the sum of each of its components, right? And so so we can just basically distribute this sum to each term and take each of these sums individually. And you don't always have to rewrite it like this, but just know that that's the case, right? Same thing with difference, right? So the sum of a difference is equal to the difference of its sums. All right, and then finally, this one, like I said, is a little different. This one says if you have a sum from 1 to n, then you can break that up and stop it somewhere in the middle at m, and then just start at that next number, whatever comes after m, and go to n. Okay, so for example, if I have the sum of, let's say, from 1 to, let's say, 8 here of, let's pick, let's say 1 over x, okay? So that would be, like I could write it this as, this would be 1 over 1, right? Start with 1 over 1 plus 1 over 2 plus 1 over 3, all the way up to 1 over 8, right? Oops, I've skipped 6. Oops, I got close to my tool there. All right, so now, so another way I could write that is I could say, okay, well, that's the same as saying I equals 1 to, let's say 3 of 1 over x plus, and now instead of, since I ended at 3, now I'm going to start at 4, so I'm going to go from I equals 4 to 8, okay, of 1 over x, right? And that would be the same thing as saying this, right? Because this will get me up to 3, right? And then this will get me from 4 all the way to 8, right? And so so you can break up a sum that way too. And sometimes it's beneficial to do that. And so that sometimes becomes a helpful law there, or rule, or property. All right, so those are some properties of sigma notation.